In this tutorial, we'll answer the two questions: what is heat transfer and how heat is transferred. So for the first question, the what question, we'll define heat transfer as the thermal energy transferred from one system to another due to temperature difference. So the first requirement for heat transfer to occur is the existence of a temperature difference. So this is the first requirement. So first requirement, delta T, the temperature difference, should be different than 0. Then we can say that heat transfer exists. So this is similar to saying that fluid will flow only when we have a total pressure difference. So when delta P is different than 0, then we can say we have a fluid flow. And also, this is similar to saying that we have current flow only when there is a voltage difference. So when delta V, the voltage difference, is different than 0, then we can say we have current flow. So this is the first requirement. Delta T is different than 0, we have heat transfer. Delta T is equal to 0, heat transfer does not exist. For the second requirement, we'll talk about the directionality of heat transfer. So we should know that heat is transferred in the direction of decreasing temperature. So heat is transferred in the direction of decreasing temperature. Or in other words, we can say it is always from hot to cold. So the direction of heat transfer is always from hot to cold. And similarly for fluid flow, so fluid flows in the direction. So you should know from fluid mechanics that fluid flows in the direction of decreasing total pressure. And also current flow in the direction of decreasing voltage. So now, till now, we have two requirements. First one, delta T different than 0. The second one is heat transfer from hot to cold always. So we can also prove this using the second law of thermodynamics. So you know that the second law of thermodynamics specifies the direction of a given process. So the direction of a given process should be always in the direction of the increase of entropy principle. So from the increase of entropy principle states that the direction of a given process, should satisfy the following equation. Should satisfy the equation that the generation of entropy as generation should be always greater than or equal to 0. So any process should satisfy this equation, meaning that entropy is always generated and cannot be destroyed. We can use this equation to prove that heat is transferred in the direction of decreasing temperature. For example, if we take a brick wall This is a wall. And from one side, the temperature of the wall is at high temperature, T hot. Maybe here we have outside conditions, summer conditions, the temperature is high. And this side is at a lower temperature, we call it T cold. So here it is subjected to indoor conditions. We have air conditioned room, and the temperature of this side is at a temperature less than T hot. So as we said, the direction of heat transfer is always from hot to cold. So we can say that the Q, which is the heat transfer rate, is from T hot to T cold. Let's apply an entropy rate balance to this wall. So entropy rate balance. So you know that the entropy rate balance, ds over dt, it is the rate of entropy transfer to the system. So S dot n minus the rate of entropy transfer out of the system. So this dot means we have a rate of entropy plus S dot generated. Now at steady state, there is no change of entropy with respect to time. So this is equal to 0. The rate of entropy transfer to the system. So our system is the wall. We have heat transfer to the system. And this heat transfer will include an entropy transfer. So you know that entropy is transferred either by mass or by heat. So here we have entropy transfer by heat, meaning this is equal to Q over TH. So to the system, the heat is transferred at the side where the temperature is equal to TH. Now the entropy transfer out is the heat divided by the temperature T cold plus the rate of entropy generation. So we can say that the rate of entropy generation in this case, we can take Q as common factor, is equal 1 over T cold minus 1 over T hot. So T hot is greater than T cold, so that the inverse 1 over T cold minus 1 over T hot is positive, meaning the rate of entropy generation is positive, which satisfies the increase of entropy principle, meaning that the direction of heat transfer is correct, which is from the hot side to the cold side. And even if you don't, for example, remember the second law of thermodynamics, you should accept these two requirements. The first one is that delta T should be different than 0 for heat transfer to occur. And for the second requirement, you should accept that heat is transferred in the direction of decreasing temperature from hot to cold without the need to apply the second law of thermodynamics. Now we've answered the what question. Let's try to answer the how question. So how heat is transferred. You should know that we have 3 modes of heat transfer. The first one is called heat transfer by conduction. So this mode of heat transfer occurs when delta T exists, delta T, when we have a temperature difference through solids or fluids at rest. So for example, to understand conduction, let's take a metal rod and let's heat this metal rod at one end using any heat source. So we have the temperature here at this end equal to T1, and let's measure the temperature at the opposite end, we call it T2. And this metal rod is put into an ambient temperature where T is equal to T surrounding. If we measure T2, we will notice that T2 is greater than T surrounding, even if T2 is far from the heat source. So this probe here is far from the heat source. However, we obtain that T2 is greater than T surrounding. And the reason for this is that heat is transferred through the metal bar by conduction and it will reach the opposite end. So that's why we have T2 greater than T surrounding. However, T2 should be less than T1 since T1 is near the heating source and T2 is far from the heating source. So this is near and this is far. Okay, so this is the first mode of heat transfer. For the second mode of heat transfer is heat transfer by convection. So it occurs when we have a temperature difference, when delta T exists between a moving fluid, so here we talk about motion, and a stationary solid. So mainly we should have a moving fluid and a stationary solid. And in convection we have two types of convection. So we'll talk about two examples. The first one, let's say we have a hot egg and we have this fan that is blowing air over the hot egg. So we have air here. So we say we have heat transfer by convection, Q convection, from the hot egg to the moving air. So here air motion is caused by the fan. Air motion is caused by an external mean. In this example, we have a fan. It could be a pump if we are talking about liquids. So we say that the motion is forced. So we classify this type of convection as forced convection. So in forced convection, the motion of the fluid is caused by an external mean. In the second example, if we take this hot egg and we leave it to cool by itself without forcing the air to move over this hot egg. So what will happen is that the air near the egg will get warmer. So when the air gets warmer, its density will decrease and it will become lighter, so it will rise to the top. So here we have warm air, which is lighter. That's why it will rise. And the surrounding cold air is heavier. So here we have cold air that is heavier, and that's why it will drop. And the cycle will continue. So the cold air will become now in contact with the hot egg, it will become warmer and it will rise, and so on. So we have this motion here. So the air motion, we can say the air motion is caused by the density difference. And the density difference is caused by the temperature difference. So which is caused by temperature difference. And you can see this using the ideal gas law. If you apply the ideal gas law, for example, so the ideal gas law, in this form, if we say the pressure is equal to rho into R into T. So at constant pressure, we can say that if the temperature increase, the product of rho into R into T should be always constant. So if T increase, then the density should decrease. That's why warm air has a smaller density, and if T decreases, then the density will increase. So cold air has higher density, so that's why it will drop. And warm air is lighter, it has low density, so that's why it will rise. So the air motion here, unlike forced convection, is not caused by an external means such as a fan or a pump. it is caused by the density difference. So we say that this type of convection is called free or natural convection. Now, the third mode of heat transfer is called heat transfer by radiation. So the heat transfer by radiation, it is the propagation of electromagnetic waves by matter whose temperature is greater than 0 Kelvin. So any matter whose temperature is greater than 0 Kelvin or minus 273 degrees Celsius will emit electromagnetic waves. And in thermal radiation, we are interested in the electromagnetic waves that depend on the temperature of the body. So we're not interested in X-rays, gamma rays, or microwaves. So that does not depend on the temperature of the body. We are interested in thermal radiation about the electromagnetic waves that mainly depend on the temperature of the body. So unlike conduction and convection, so as you saw, that conduction requires a medium. So here we have a Q by conduction through the metal bar medium or metal rod medium. Here we have the convection to the air medium or to any fluid medium. However, in radiation, so radiation does not need a medium to occur. It can happen in vacuum. So the most clear example is that the sun emits radiations, and the radiation will travel through vacuum in space, and then it will reach Earth. So this mode of heat transfer does not require a medium to occur, unlike conduction and convection. So that's it. We've talked about what is heat transfer. So we defined the two requirements. The first one, delta T should be different than 0. The second one, the direction should be always from hot to cold. And we know now the three modes of heat transfer. The conduction, it happens in solids or fluids at rest. Convection, between a moving fluid and a stationary solid. And radiation, it is the propagation of electromagnetic waves, and it does not require any medium to occur. It can happen in vacuum. In the second video, we'll talk about each mode, conduction, convection, and radiation in more details.